Hi everyone. Have you ever wondered how the electric current is generated in batteries? To answer this question, we need to study the redox reactions or the oxidation-reduction reactions. Our main objective is define electric current, oxidation half reaction, reduction half reaction, oxidizing agent, reducing agent, and redox reaction. So let's get started. We can understand electrical current and why it flows by analogy with water current in a stream. The rate of electrons flowing through a wire is analogous to the rate of water moving through a stream. Therefore, the electric current is the movement of electrons and measured in units of amperes, which is symbolized by an uppercase A. 1 ampere represents the flow of 1 coulomb, which is a measure of electrical charge per second. So 1A equals 1C over S. In this given generic reaction, we can see that two substances, A and B, react together to form two products, A plus and B minus. This chemical reaction occurs when one electron is transferred from A to B, and in this case we have two processes. The first one when A loses one electron to form A plus, and it's called as oxidation process. The second one when B gains one electron to form a B minus, and this one is called reduction process. A redox or oxidation-reduction reaction is a type of chemical reaction that involves a transfer of electrons between two species. We can tell that there has been a transfer of electrons if there is any change in the oxidation number between the reactants and the products. Any redox reaction in an electrochemical cell consists of two half-cell reactions, the oxidation half reaction and the reduction half reaction. To differentiate between them, the oxidation half reaction is the half reaction where atoms or ions of an element experience increase in oxidation number, while the reduction half reaction is the half reaction where atoms of ions of an element experience decrease in oxidation number. If we apply what we have learned so far in the cell, we can find on our left hand, zinc acts as an anode where oxidation half reaction occurs, as each zinc atom loses 2 electrons to form zinc ions. These electrons will be transferred through the wire to generate the electric current to the copper ions in the electrolyte. The copper ions in the electrolyte will gain these 2 electrons to form copper atoms, and these copper atoms will deposit on the copper electrode that acts as a cathode. Also, we can compare between the oxidizing agent and the reducing agent from their definitions, as the oxidizing agent is the substance that is reduced in a redox reaction, while the reducing agent is the substance that is oxidized in a redox reaction. This image illustrates the difference between reducing agent and oxidizing agent. Here we have two substances, X and Y, and there is one electron is transferred from X to Y. So on our left hand here, X loses one electron, which means it is oxidized. And from the definition of reducing agent, it is the substance that is oxidized in a redox reaction. So X is a reducing agent. On our right side, we have Y. Y gains this electron, so Y is reduced by X. And the substance that is reduced, it's an oxidizing agent. So X is a reducing agent, while Y is an oxidizing agent. Now it's time to practice. The question says, use the change in oxidation number to identify whether each reaction is a redox reaction or a reaction of some other type. If a reaction is a redox reaction, identify the element reduced, the element oxidized, the reducing agent, and the oxidizing agent. The given equation is Cl2 plus 2NaBr form 2NaCl plus Br2. To solve this problem, we need to determine the oxidation number of each atom in the equation based on the oxidation number rules. Once there is a change in the oxidation number of any atom, such as chlorine from 0 to -1, or bromide ions from -1 to 0, so this is a redox reaction. Also, as it's shown here, the chlorine is reduced as the oxidation number decreases from 0 in the elemental state to -1. Therefore, it's the oxidizing agent, while the bromide ion is oxidized as its oxidation number increases from 0 to -1. Therefore, it's the reducing agent. So that was the end of our lesson. Thank you for listening and see you in the next video.